Hello, so let us meet the members who work for the RoboKar project. Myself, Labib Hasan, Shafin, Musfiqur, Rahman, Farhana, Taskin, Afifa, Jumana, and Taskin.
The primary objective was to develop an embedded software system for a mobile robot referred to as RoboKar in two versions, sequential and concurrent programming. We aim to design and develop software to control RoboKar, focusing on both sequential and concurrent programming approaches. We also aim to investigate the relationship between the timing requirements and the responsiveness of RoboKar. Our key focus areas included sequential programming by implementing software for RoboKar without using a real time operating system, emphasizing accuracy in following a line and handling obstacles. Our key focus areas also included concurrent programming by enhancing RoboKar's performance by implementing concurrent programming using UCOS to RTOS. This involved creating a multi-threading design to allow the robot to execute multiple tasks simultaneously, such as line detection, obstacle detection, and motor control. Our key focus was also to compare the two implementations to assess how concurrent programming and the use of RTOS impact the robot's responsiveness and overall performance. Our goals for this project were to develop a robust and efficient software system for RoboKart that ensures accurate line following and effective obstacle handling. Our goals also included to analyze and understand the benefits of concurrent programming in embedded systems, particularly in terms of improving responsiveness and performance. Our goal was also to provide insights and recommendations based on our findings to highlight the significance of using RTOS in embedded software development.
This is a short background study for RoboKar. RoboKar is actually a mobile robot designed for line following and obstacle avoidance. For this, we have used two kind of programming. One is sequential programming and concurrent programming. In sequential programming, the debugging is more straightforward and the tasks are processed in a sequential manner. That means one after another, the tasks are completed. It combines the sensor data processing, navigation, and motor control in a continuous loop. On the other hand, in concurrent programming, it uses a real time operating system to manage the tasks. It enhances the responsiveness and real time performance. The system is a bit complex, but it is capable of executing multiple tasks simultaneously.
So now I am going to explain the details of sequential programming. The first one is requirements. We have line following. The robot needs to follow a line using its line sensor. Then obstacle detection. The robot must detect obstacles using proximity sensor and response to accordingly. Then motor control. The robot should control its motor to navigate based on sensor inputs. Next, real-time operation. The robot should perform tasks in real time using a real-time operating system. Then we have multitasking. The system should handle multiple tasks simultaneously with proper task scheduling and priority management. Status indicators. The LEDs or other indicators to show the status of the robots and tasks. And last, modular design to ensure the code is modular to facilitate easy updates and maintenance. The next one is design. We have sensor input processing, task management, task functionalities, and real-time execution. For sensor input processing, we have proximity sensor to detect the obstacle, line sensor to enable the line following. For task management, we have priorities to ensure the real-time performance, and we scheduling the functions for task management. For task functionalities, to check collision task, monitors proximity sensor, and update obstacle status. Control monitor task to read and set the motor speed, and navigation to adjust the motor speed for line following and obstacle for avoidance. And the last one is real-time execution. We have periodic execution of tasks using time delays for sensor checking, motor control, and navigation. Then we have programming tools. We use AVR Studio to integrated development environment for AVR microcontrollers. Arduino for open source electronic platform for prototyping. RoboKar HAL for hardware abstraction layer providing control over the robot's motor and sensor. And the language is C programming language. And for compiler, we use the Aviate GCC. Now I'm going to talk about the details of concurrent programming. So concurrent programming involves executing multiple tasks simultaneously, enhancing system efficiency and responsiveness. So the benefit of concurrent programming is improved performance, enhanced responsiveness, resource utilization, and scalability. And the key features are concurrency control, parallelism, efficiency, and flexibility. Now I'm going to talk about the code of concurrent programming. So the first one is RTOS usage. You goes to RTOS on multitasking, OS unit function initialize kernel, and OS start function begin multitasking. These are used. And then task definition and prioritization. And tasks are being prioritized based on the RoboKar. So task start priority, which is the highest, which is one. Then task check collision. Then task is control motor, and then the task is navigate priority. And task stack allocation is 128 bits per task. Then task creation, task OS task creation function is being used to create task. Then we have used global shared variable, which robust structure is used for robust structure for speed and obstacle status, and used for semaphores to protect shared variable. Then if we look at the task overview, there is this check collision, then control motors, and then navigation, and then task start. The here is our main function, which initialize hull and RTOS, says initial motor speed and clear obstacle status, create task start and task start and starts RTOS, then enters infinite loop, and the last one is task scheduling, which is managed by U post 2 based on the task priorities.
Now, let's talk about the design and implementation of concurrent programming. As a requirement, we at first have real-time responsiveness, which ensures timely responses to environmental changes, and then task prioritization. So assign priorities to tasks and ensure critical tasks are executed first. Then we have resource management, which is actually efficient allocation and management of the system resources we have, like CPU, memory. And then we have inter-task communication, which is the mechanism between the tasks so that they can communicate and share data safely. So then let's talk about the design. For RTOS, real time, we have UCOS2, and as a task structure, we have check collision, which actually monitors proximity sensor and updates obstacle status, and control motors, which controls the motor speeds according to the current states, and navigation, it handles the navigation logic and adjusts the speeds based on the sensor inputs and obstacle status. Then we have shared data structure, which contains the motor speeds like right speed or left speed, and obstacle detection flag, which is called as an obstacle. And as a task priority, we have assigned based on the criticality of tasks to ensure timely execution. For scheduling analysis, we ensure that each task meets its timing constraints, like each to check collision every 100 millisecond or control motors every 5 millisecond. Then we calculate the worst case response time for each task to ensure it meets the real-time request.
So this is the comparison of sequential and concurrent programming based on the testing and performance. The key aspects are the execution order, the debugging, the task processing, the responsiveness, the code modularity, the line following accuracy, and the scalability. So at first, the sequential programming, the execution order is very linear, and then the concurrent programming, the order is parallel. For debugging, the sequential programming it's a bit slower than concurrent programming, it's faster. For the task processing, sequential programming speed is moderate, and concurrent programming speed is high. The responsiveness for sequential programming is almost 850 millisecond, where the concurrent programming, the responsiveness is only 250 milliseconds. The code modularity for sequential programming it's tight functions, and in concurrent programming it's independent tasks. So overall, these are the differences between sequential programming and concurrent programming.
Now I'm going to explain about the conclusion. So concurrent programming with microcontroller operating system and real-time operating system significantly enhanced RoboKar's performance. A mobile robot for line following and obstacle avoidance. Using real-time operating system, RoboKar achieves better responsiveness, resource utilization, modularity, resulting in a robust and scalar solution. Let's discuss the key benefits. First of all is improved performance. Optimized hardware uses by executing tasks concurrently. Second, enhanced responsiveness. Handles real-time tasks effectively, responding promptly to sensor input and environmental changes. Third one is resource utilization. Maximum CPU and input-output device uses, reducing time. And the fourth one is scalability. Easily handles increased workload by adding more tasks. This project demonstrates the importance of real-time operating system in managing multiple tasks for real-time application. The successful integration of microcontroller operating system in RoboKar highlight the advantages of concurrently programming and in enhancing RoboKar functionality and reliability, showcasing its potential for advancing to real-life robotic application. Thank you.